So, I think I switched my laptop for second screen, but I don't see anything here. Okay, yes, I didn't switch PowerPoint. Dot. Once more. Okay, it works. Now, I didn't put anything about great women, and the reason is very simple. Every time when I see something about great woman, I ask myself, and what is special in it? Why? I can explain probably. My grandmother, she never attended the school or gymnasia. She started her education from university. She was graduated as a medical doctor, and she was medical doctor for her life until she discovered tumor in her own body. So it was down count for her, and she knew very well how down counter works. My daughter was 4 years old. My wife went for a work trip for a couple of weeks, and not big deal for me to live with 4 years old daughter. She was not a baby. But my grandmother came to me and said, no, I can help you. She was cooking. She was, in large extent, taking care about our daughter, her granddaughter. So, and she helped me a lot. And it was 6 weeks before she died, and she was 90 plus. Can I be the same in strength and courage? I don't think so. My sister, she is a full professor expert in child neurology. My wife is full professor expert in marine biology. I wanted to be marine biologist when I was in school, but I didn't. I was in science. I never reached such levels. So I feel myself as a retarded boy in this family. And you say me, the great woman is not normal. Of course it's normal. I cannot pick up one. No. I worked with LabVIEW for quite a long time. And my main area of interest is software architecture, object-oriented architecture. I work for Novator solution for 10 or more years already. So Novator Solutions is a company established in 1980s. We have 3 divisions. At right side, this is oldest division, is remote measurement. Own product, it is own design of some kind of computer sitting in a box, place it in remote place, sending signal customer orders, what to send, measurement results to satellite or to other net without any maintenance for a year or more. So it's quite profitable for customers. But this is old. Another division at left side, this is spectral data analysis. It's filtering analysis, broadband data, a lot of information storing in rates, playback, such type. This is products. Again, this is newer product division. Here we use NI equipment and we put LabVIEW software on it. So in first division, in remote measurement division, the software is LabVIEW, of course. 2. And main division in Centrum. Why is it main? Because I work there. It is consulting services to our customers. So now my presentation. Why do we need multiple inheritance? Concept of classes, new type of classes. I hope I found a way to create them. Toolkit to do it. And non-canonical behavior of object-oriented behavior of these classes. So, question and hopefully brainstorming. Now, this is my hobby project. So everything is on my own initiative. I really would appreciate feedback, brainstorming, pointing bottlenecks in my solution. The toolkit is the minimum. It is only to be able to work. So why it's minimum? Because now it's proof of concept. On base of your feedback, I will develop concept and create more advanced functionality in the toolkit, maybe change the toolkit if concept will be changed dramatically. Now, example, why do we need multiple inheritance? Let's take a simple DAC workstation. Let's say we want to measure voltage and we want to have some I/O. Great. We bought a couple of units. One is measurement, voltage measurement, provide voltage measurements. Second one, I/O. And we create reasonable class hierarchy. DAC representing the unit and units as specific classes. But we are extremely successful with our project. And we want to build a new second workstation. And now we search for available solutions, probably on eBay, and we buy USB 6009, probably second-hand, very cheap and extremely good. So, but now we have problem. We have two classes and we have only one device, which does the same. We do some simple fixes, no problem, and we work with our software. We don't want to write second program just for second workstation. But tomorrow we want to extend, and we buy a unit which has measure voltage and probably frequency. And tomorrow even more. We bought units which measure voltage, count impedance, and count number of cats in presentations of this conference. We have problem here. How do we implement that in architecture sense? It's completely mess, a lot of fixes. But thankfully we have interfaces. So we can say, okay, our main structure represents devices. In this case, we don't care what each device measure. We put device, we can put more layers, some combine specific things for device, for example, USB and PXI, probably other type of devices, and put our specific devices in specific classes. And in our architecture, this structure represents hardware. And functionality, we represent as interfaces. Interface for voltage, for digital I/O, and for other measurements, including counting of cats. I don't put them here to avoid very crafty diagram. So, what we have here, we have very good abstraction layer, but we still have a problem. We have a problem that we must implement the same things in our specific classes. Not completely, because LabVIEW interfaces are not canonical interfaces. They allow to have some code, but they don't allow to have interfaces. This is summary. So class can inherit from many different interfaces. This is in previous page we see this device 3 inherits from two interfaces and from main hardware class. So LabVIEW interface can have often non-abstract methods, dynamic dispatch or static. Unfortunately, interface cannot have attribute. It means that the particular values or settings or whatever must be saved in each specific class. And because of it, it's a lot of code working with attributes. Or you put libraries aside and you have a lot of code communicating between attributes and libraries. So, but this is the only one limitation, attributes. Can we solve it? Yes, and if we solve it, we get our multiple inheritance. Class has many parts. Of course, we speak about advanced computer programming. I would never recommend it for one who just started working with LabVIEW or maybe got CLAD certification. Of course, there are very, very talented people, but I say about our expectation from people from this experience. What is requirements? Use available tools. Use basic LabVIEW code. And hopefully don't put any DLL and don't put anything in VI-lib. So it means the code has to be portable to a computer which doesn't know anything about AZM toolkit. So it must work with basic LabVIEW functionality. So, and we can do it. Now, interface. What is interface? Interface is canonical interface in handbooks. It's descriptor. It describes data type and it describes methods. So in LabVIEW, it is method is described with name plus terminal pattern. But in LabVIEW, we can have code. And this code is completely legal as long as it does access attributes or properties. So interface is not a class because attributes are missing. Now, but good old functional global variables. We can put it in code of interface. It's completely legal. It will keep our value in non-initialized shift register. So we add to our interface type definition for this attribute cluster, as we do it in conventional classes, whatever model do we use for classes. And we have this functional global variable, which I call accessor. Why it's accessor? Because it will be developed as accessor in future slides. So, but we got one set of attributes for all instances. So, what we got? We got a singleton. And singleton, personally me, I hate singletons. I use them if I really cannot avoid them. There are people who love singleton, but I believe there is no one who implements more singletons than regular classes. Just, it's a question of architecture. But we have a map. And if we have a map, we can use different sets of values, different copies of the same cluster for different instances of our class, for different objects belonging to the same class, or maybe different classes. But there is a question. What is key for this map? And this would be a perfect solution if we can use the interface var as key for the map. Is it possible? No, it's not possible. Because the var, even interface var, class var of course, carries the whole cluster of information. And this is simple text. We take, as input, we take an object, and we assign value to attribute, and we create a map. After that, we change this value, we add this value to the map, put, this is put method, generally speaking, and we got size of map 2. Map doesn't recognize that this is the same instance. And opposite test. If we have two different copies of the class, two different objects, and assign the same value to all members of the attribute class, we get size 1. It does recognize difference. So requirements. Key must be unique for each object, and it must not change during whole life of the object. Can LabVIEW class satisfy these requirements. Yes, GOOP classes. What is GOOP class keeping in the wire? It's only reference number. And this reference number is created in object constructor and destroyed in object destructor. It never changed. So we can have such a map. So in interface structure, we have now the same type definition for attributes plus attribute accessor. So now we have our accessor, which has a map stored in non-initialized shift register and guided by wire, and it works perfectly. The only one thing beside of set and get, we need cleanup, because we have to remove our member of the map class object if object is destroyed. So otherwise we have a memory leak point. So now interface is converted to class. Interface with code, with attributes is not interface, it's fully capable class. And let's call it iClass, yeah, to have it different from interfaces. But unfortunately, only GOOP classes can be used here. We come to it a little bit later. So, and of course, when we create dependency between interface as a parent, interface iClass as a parent, and our GOOP class, we must put clean up in the destructor. So now, inheriting from iClasses, is this solution good enough when we do it? Actually, it's okay. But there are two things. There is no attribute locking mechanics here. So we have to get value to update one member of the class, of the object cluster, and set it. And between those two, there is all chances to interfere. So we need some way to lock our attributes when we update them. And second, it's not a problem, but it's great inconvenience, because setting of value with GOOP and with iClass have completely different code. What does it mean? It means that if we develop our project and want to lift up some attribute to iClass, share this attribute between different children, we have to rewrite code everywhere manually, because it's very, very different. We cannot do anything automatically. So, solution, use data value reference everywhere, in GOOP classes as they are, and in iClasses. Now, this is how it looks, our accessor. So now we have 4 members of our 4 options when we call our accessor, because we have to create our data value reference. And we must create it when we construct the object, because this data value reference must have the same lifetime as the object. So we have 4 options, and because it is working with GOOP, get and only DVR is similar to GOOP attribute accessor. Now we have almost identical code for accessing and for writing attribute to GOOP attribute cluster and to iClass attribute cluster, and even we can use which type of the solution. So log them at the same time. So race conditions are prevented with in-place element structure, and same approach for different type of attribute update. Now, toolkit. Again, toolkit is extremely bad in sense of quality of the code because it is just try and error concept development. I already started to work on better code, improvement of functionality, but I don't force it before I get feedback, as I said. So you can get this toolkit from me on USB today, on USB tomorrow, or by email if you give me email. But I will not share it through internet because I will blame it for the rest of my life. So I give it, but I know to whom I give it. So at least you are warned. It's dirty code. So now how it works. I take interface. So far there is no create iClass. You have to create interface manually and convert it to class. And actually it supplies interface with two members. After that, I want to create dependency. So I pick up GOOP class, I select set parent interface, don't look for control consistency, it's not implemented here yet, it's implemented in another way, I will show you. So set parent interface and you have list of all interfaces and iClasses available. Why interfaces are here too? They are not classes, but they still here, and you will understand why it's better to use this one to set dependency on interface if you use iClasses when I come to the chapter or part of presentation which is called non-canonic behavior. So now if you select, no, it's okay. Yeah, or if you select one, so you get, no, what did I do wrong? Okay, if I do so, no, I have something else, sorry. It doesn't click anymore. Okay. No. No. Okay, now it started, yeah. I think it lost focus. So, I create dependency, but pay attention. Initially, there was no dependency between interface and class which we set as child class. And constructor and destructor code are getting calls for constructing and destructing of our interface. Now, interface class. What happens if dependency already was established before we converted interface to iClass? There is tool among tools which is called control consistency. So you get such an interface, and simple interface you investigate. Do you check hierarchy of interface classes, or you check GOOP classes if they have constructors and destructors, and repair from here. So after that you get, if you select, you get the same user interface where you can select items, what to repair, if it's repairable. Otherwise it is grayed out and you can attend it and check something manually. For example, if you call constructor of iClass 2 times, program cannot recognize which one is right, which one is wrong, and why is it wrong. So I have two different buttons here. Probably I should assemble them in one, but again, you say what is better. I don't know yet. So now, limitations. Limitations are conventional class can inherit from many secondary parents and from only one main GOOP4 parent. But there is no way to convert between convert I class to GOOP class and vice versa. So we have primary and secondary parents. Still, they can behave exactly in the same way in architecture level, but in sense of implementation, they are not convertible to each other. It's limitation. I class is always abstract. Even if it has no abstract methods, it's abstract. You cannot instantiate it because the var itself has no any reference number. You have to create some kind of dummy GOOP class which will do nothing, just construct and destruct. This is it. GOOP classes, I classes can be used only with GOOP4. Probably they can be used with GOOP3 and G# classes, but I didn't test it yet. They never can be used with native LabVIEW classes, with by-value classes. And there is non-canonical behavior. Now, what is canonical behavior? Subclass is superclass with added or overridden methods. So, members, methods, and attributes. So, what does it mean? It means that for inheritance, that GOOP class can inherit from GOOP class, interface can inherit from interface, GOOP class can inherit from interface. So, in this case, we offer to user of this in software sense, user of this class, we offer all functionality of superclass when we create instance of subclass. And because now we have second type of classes, I classes, we say I class can inherit from I class, GOOP class can inherit from I class, and of course I class can inherit from interface. And this is canonical behavior. But for LabVIEW, we used basic LabVIEW functionality to create this type of classes. It means that for LabVIEW, I class is an interface. LabVIEW doesn't recognize difference on sense of the project members and sense of what is it for LabVIEW. It means that it's completely legal to have dependency, such dependency, interface, from interface canonical dependency, but now we convert, again it started, stop to work, no, no, no. This is something I think I have to find somewhere here. Yeah, now we convert our parent interface to class, and it's completely legal. Interface depends on class. What does it mean? It means we take out attributes from I class, and it's okay. We put attribute, and we didn't change interface, child interface, and it's not okay. But child must offer all functionality of superclass. It means interface to here is a class. Even more, we can have dependency of GOOP class from interface and dependency from I class. And what is it? Is interface to class if it depends on class? We don't change anything in the code, but we change it from class to interface and vice versa, just removing and adding parent. It's crazy. How do we solve problem? There is no solution. Only agree on. If interface depends on, inherits from I class, it is I class. Yes, if we remove dependency, it's back to interface, only aggregate. But I have an excuse. Native classes are fully functional without any attributes. So such interface, okay, this is I class without attributes, exactly the same way as native classes. Now, there is a website, AZeta interface net. AZeta, it's because I am Andrei Zagorodni, and this is ego-driven project. So when the code is ready for public, I will put it there. But if you give me or send me email, I will create a mailing list and send directly to you code if you wish. So maybe in far future I will put it in some repository, but it's not first what I will do, simply because there is a lot of other things to develop in this toolkit. First of all, develop basic functionality, reliable. After that, add necessary functions like create iClass from scratch and so on. So putting it in some public repository, it is very far away. But here, first functional version will be here. And if organizer will not put all lectures in one place, I can put lectures there next week in the same website. So now it contains previous toolkit for creating interfaces in older versions of LabVIEW, which had no interfaces, versions 19 and before, but nobody needs it. I will not remove them, because if somebody find a version which was attended by some other developer, I will be blamed. So better if somebody wants, he can look in it. No, what is forgotten? It's a question to you. What is wrong? What can be done better? And what can be improved? Thank you.
Yeah, so I had a similar issue where you kind of one day you use DACMX something, and another day you use some Visa thing, and like you started your presentation with, you want to sort like voltages, the digital, etc. And I kept it that way, but instead I solved it with friend classes in LabVIEW, where kind of you would have a DACMX friend class or whatever, and it would carry the reference, and they will grab it for that, because often the main problem for me was that, well, you make the reference here, and then you also want the reference in the digital and the analog, and then how do you share it? And by using a friend class, I got around that. So I was wondering, have you tried this solution for your?
Yes, of course. This is actually friend classes or encapsulated classes. Or say aggregated classes in terminology of UML. It's part of, for example, GOOP package. Yeah. So there are such classes. They are not, so, to be frank, I'm not happy with them, because it's a lot of extra code. It's parallel hierarchies, which must reflect main hierarchy. So sometimes I use it, but I believe multiple inheritance is just more powerful tool.
Yeah, I don't disagree there. They're native to LabVIEW, but I always try to use the native LabVIEW tools.
But with native LabVIEW, there is no anything to add on it.
No, it's just I didn't need the, what can you say, I didn't need to have a parallel hierarchy that was similar. It was just one class which called DACMX, one class which was USB, etc., where the reference was solved, but maybe.
Yeah, I don't say you cannot do it. Of course, there are every problem can be solved in many different ways, but you know, my feeling is more simple to implement second parents than create and keep references to different type of classes. We'll do it, I believe. And even having multiple inheritance, in some cases, it will be more reasonable to use solution which you. But I don't like, to be frank, I don't like to using friend classes. So let's say so, you are first person who I see with my eyes who use friend relationship. So usually it's more like aggregated classes, compositely aggregated classes. But of course, objects, not classes, objects. Yeah.
I don't know if you have already answered this question, but what problem are we trying to solve?
In architectural level, we want to, in this example, we want to decompose hardware from functionality. So, but there are many examples when we have different things which we are forced to assemble in the same class. So, in architecture level, in this example, the GOOP class structure represents hardware. It doesn't care about functionality. I class structure represents functionality. It doesn't care about hardware. Actually, in the toolkit, so I have a structure of inside a new version, not with first what I work now. I have a structure of classes representing different project members, just to search which classes, dependency between them, and so on. But toolkit and concept is not applicable to native classes. It's applicable only to I classes and to GOOP classes. As a result, I have interface which is parent to GOOP 4 type classes and 2 I classes which represent classes which are affected by change in I class structure. So I class is child to interface, and after that child to LV class library. GOOP class is child directly to LV class library. So, but I have some kind of side branch with parent, which represents only classes which are changeable, repairable, and brokeable, we can say, if we do something wrong, which has to be involved in this in the changes. This is another example. Yep.
Sure, this is probably a bit of a silly question, but why didn't NIM implement this functionality? Because we have it in classes already,
Look.
so why didn't they carry it over to interfaces?
When I presented interfaces in, it was 1918, in oh, no, not 1918. No, sorry, 2018. So I presented interfaces in CLA Summit, and I picked it up, and of course they thought about it before, I cannot say, but at least after that they offered them in LabVIEW 2020. Maybe they will do the same now, and I will be happy, actually.
Okay. Thanks very much, Andrei. Cool.